In this demonstration, I am going to attempt to make sodium chloride. A very cool reaction, one of my favorites, as I always like to say. But in order to make sodium chloride from its elements, I'm going to start with elemental sodium, which I have here, a very sulf-reactive metal that is stored in kerosene, because the kerosene, being nonpolar, is hydrophobic, prevents the water from reacting with it, as you've seen in other demonstrations, or mine. And I'm going to generate the chlorine gas, the chlorine atoms, okay, from potassium permanganate with hydrochloric acid. So the potassium permanganate, being a strong oxidizer, okay, is going to make the chlorine atoms become into chlorine atoms, chlorine ions. And from the hydrochloric acid I'm going to add to the potassium permanganate is going to become the chlorine gas here. And you know the chlorine gas is present when you see a yellowish green. There's a little bit here that I've made previously, but I'm going to pump it up, or pump up the volume, so to speak, with some acid or hydrochloric acid. So it's the chloride ions reacting with the permanganate ions, and the chloride ions, being Cl negative, are going to lose the electron, okay, be forced to oxidize by the presence of the oxidizing agent, the potassium permanganate, the permanganate ion, to make your chlorine gas. So let's make some chlorine gas. So I'm going to put some hydrochloric acid into this Erlenmeyer and then stopper it. And as I should mention, I'm in a fume hood because I am producing, okay, chlorine gas, and trying to fill this flask up with chlorine gas. I'm not quite seeing the volume of gas. I'm not seeing that color change drastically, so I'm going to have to put some more acid here. And I may need some more potassium permanganate. But the flash should get yellowy green. Okay? And let me just add, just to make sure, because I want to make sure I'm filling that flask up. And I see it getting yellowy green, but I'm just going to add a little bit more potassium permanganate into the mixture, the chloride ion mixture. And of course, you can see that green color, that yellowish green color. So you can see that flask is definitely filling up with a greenish yellow color of chlorine gas. So I believe we're ready to rock and roll here. Okay, at least I can see with my colorblind eyes. You agree? You see some chlorine gas in there? Okay, we're in a fume hood. So now all I'm going to do is I'm going to take out my generating tube, and I'm going to drop some small amount of sodium into the flask. Now, it may react right away. Chances are that it won't, so I'm probably going to have to put a little bit of water on it. Okay, so I'm going to take out my generating tube. I can see my yellowy flask, and I'm going to take my piece of sodium, and I'm going to drop it, hopefully, right in the middle. Okay, reposition my camera a little bit. Okay, now, let's see if we get a nice little close-up here. What's going on? And refocus. And what we're going to do is I'm going to drop some water on this sodium metal to activate it. And we should see a pretty brilliant reaction once I activate it. So I'm just trying to drop some water with a pipette to start the reaction. And there it is. And that white smoke you see is sodium chloride solid. It's a colloid. And so that white smoke is the presence of sodium chloride that we made. And as it dissipates, we'll see where the sodium was, or where the sodium metal was, is now should be a crystal lattice of sodium chloride. Notice the color of the flame was indicative of how sodium metal, or sodium electrons, get excited and, of course, emit energy. So as this calms down, okay, we notice this is pretty thick smoke because this is essentially sodium chloride. So I can actually pour this out because it's really solids. But what I want to do is I want to wait to see what it looks like after it's done. When it's done, when all that sodium chloride dust settles, we should be able to see a crystal lattice in the spot where the sodium was. So once the dust has settled, so to speak, we're left with an Erlenmeyer flask that's kind of milky white on the outside. That's where the sodium chloride dust has settled. But if you look very carefully, you'll see a white spot. That white spot, and I'll get a close-up in a second, represents where the sodium was in highest concentration, and that is where you see some solid sodium chloride crystals. So let's zoom in to some very close space, and you will see right there, as I focus, that is where the sodium chloride is in the place of where the sodium metal was. So the sodium chloride, sodium plus ions, gave their electrons in a redox reaction to the chlorine ions, or the chlorine, I should say, atoms, and became chlorine ions, and they attracted each other to form this precipitate or salt. And that was that cloudy white substance. So again, a very cool reaction. Glad you were on board with it.